All right. Hello, everybody. Thanks for joining. My name is David Klotz with Enola Technologies. Just wanted to say I see people coming into the webinar, so we're going to wait about 1 or 2 minutes, and then we will go ahead and get started. So thank you all for joining, and we will get started shortly. Just watching people come into the meeting right now, so this is good. All right, seeing some more people come in. We'll get started here in just a moment. Thank you all for taking the time to join with us today. All right. Perfect. We're 2 minutes after the hour, so we'll go ahead and get started. Hello, everybody. My name is David Klotz. I am the Director of Federal Accounts at Enola Technologies. Thank you so much for joining today. We have a great discussion for our webinar. We have Carl Jolma from GS Engineering and Neil Patel. I'll be giving their introductions here shortly. Before we start, our goal is to have this discussion end right around the 45-minute mark. If you have to jump early, but you have questions and you want to make sure to get those in, please use the Q&A feature. There's also a chat feature, but the Q&A is where we're going to be looking first. So if you have any questions for either of our speakers today or just in general, please put them in the Q&A section as we go. And even if you have to jump early, I'll make sure that we answer those at the end. And then later today, we'll be sending out the recording to all the attendees. So you'll get all the great content that we are sharing today on our discussion, MBSE that ships, what works and what doesn't. So again, thank you for making the time. All right. So very quickly, who are these speakers and the companies that they represent? So first and foremost, GS Engineering is a US-based firm. They focus on blending mechanical and electrical system design, simulation, prototyping, and validation to serve defense, commercial, and specialty industries. They have a focus on engineering with purpose mindset. They emphasize disciplined systems engineering, model-based workflows, and real-world impact. So they have a wide variety of services and offerings. They work in a lot of different industries and provide a lot of engineering expertise and value to the customers that they serve, both in the US government and beyond. And then today we have our company, Enola Technologies. We also are a US-based engineering services firm. We focus on delivering mission-critical outcomes using digital engineering and model-based systems engineering practices. We mainly focus on upskilling and upstaffing your teams, and we do that through training, workshops, consulting, and support hours, as well as personnel and resource staffing. So we have an excellent bench of highly experienced engineers who have decades of experience in model-based systems engineering, including our CEO, Neil Patel. So if you want to find out more about us, please feel free to hit us up on LinkedIn or our contact information, which we'll present at the end. All right. Our speaker today for GS Engineering is Carl Jolma. He is the Systems Engineering Team Lead at GS. He has co-authored the GV sets and SAE work on AI-assisted MBSE adoption and has tailored analytical design synthesis methodology, that is not easy to say, used in real-world programs, including the U.S. Army's Heavy Assault Scissor Bridge upgrade. And then conversely, on the Enola side, we have one of our founders and principal engineers and CEO, Neil Patel. Neil has had multiple leadership positions, including that of lead systems engineer for the Navy's hypersonic missile and several positions within DoD projects. Early in his career, he was a solutions architect at NoMagic, where he helped develop the Magic Draw Cameo toolset. So Neil and Carl, thank you so much for being our speakers today. Our first topic on our webinar for MBSE that ships is really focused on the value and importance of model-based systems engineering today. So Carl, this first question is to you. Why does MBSE still matter today?
Yeah, that's a good question. MBSE has been around for a few years now, and it's there was a potential that MBSE could have been a fad, and it could have peaked in popularity, and then as results weren't seen from the new technology, it could have lost favor. But I see MBSE as still retaining popular interest or an industry need that's present today, and I think that's because it really provides value to the people that use it, and the people that consume MBSE outputs. So the value proposition that we see primarily is as a communication tool for development teams developing complex systems. Peter Senge talks about developing a shared mental model among development teams as critical to really being effective and effectively developing product. And I think this is where MBSE really comes into play. The system model that's developed as part of an integrated development effort, including MBSE, really provides that shared graphical understanding of the system architecture and how the user needs that are, or client needs that are provided can relate down to each and every engineer working on that development effort. Whether he's working on a wheel or a tire or a piece of code or whatever it might be, there's the system model can really visualize that traceability across stakeholder boundaries, and it's really effective for making development teams work together and achieve a common objective, especially when we're dealing with highly complex and integrated systems that include software and hardware and so on. But yeah, that's really the value proposition I see is still as the primary value proposition for MBSE today, and that seems like a stable value proposition moving forward, especially in the world we live in today. But Neil, I'm curious what you think.
Yeah, it's a very similar thought process as you call, right? The value of MBSE, I think, is shown through the traceability from requirements into document-based models to Monte Carlo simulations and various other simulations, and then down to PLM, right? It creates a traceability from one tool to the next and kind of creates this thread across multiple facets in your engineering cycle, right? And then not only that, setting up the MBSE today lets us go to the future, right? So part of it is as we build all these pieces and components and parts, eventually in the future, we can field and develop the next generation quicker, right? So if we've developed engines in the MBSE world where you can take it and simulate it, when you develop the next vehicle that needs the same engine, you can drop it in and simulate it. So it gives you the runway for quicker development in the future as well.
Well, perfect. I think those very well articulate the value and why it still matters today. So Neil, when thinking about MBSE that quote unquote ships, in your experience, what does that mean in practice? And then I'd love to get Carl's take on that as well.
Yeah, so when you have MBSE that ships, right? So one of the biggest challenges we see here is setting up things properly and setting up things the right way, right? So MBSE that ships requires the groundwork to be laid properly. What that means is profiles, stereotypes, different things are designed with the overall picture in mind, right? So you create an image, a plan, and then ship MBSE to your lower down programs, and then from there they can implement it, and then as they develop, it all kind of rolls back together. Then I'll pass it, Carl.
Yeah, just building on that. The way I look at it is MBSE that ships really results in outputs that are used, whether that's used by the development team or by clients or end users or other stakeholders. But if we're building, we're putting all this work into system models and building this content, it's no use to anybody if it's not used by anybody and valued by those people. So in terms of practical MBSE and making sure that the MBSE you develop is used downstream, I think it's critical to know the consumer of the model and tailor and scope the content you develop to them. So one example that recently occurred in my work was a project where we focused on safety design. We went into this project for a client, and they wanted MBSE support, and we sat down at the beginning of the project and really asked them, what are your objectives and what are your needs? And one of the needs that they had was in safety and reliability analysis. So what we ended up doing is building products that met that need, and it really engaged the development team, and it allowed us to effectively drive decision making and support the development team and take work off of their plate. And we really got engagement and value from the system model development that we did.
Perfect. And I actually think that leads really well into our next topic. Before we jump over, if anybody does have any questions on that first topic, please use the Q&A feature up top, and we will make sure to get to that towards the end. All right, so Carl, you were talking about the utility of those models downstream. So I think that actually segues perfectly into driving adoption across the workforce, which was our second topic for the discussion. And then the first question is, how can MBSE be adopted by the full workforce, not just systems engineers? And this is something that I know at Enola, we hear from our customers all the time. So I'd love to get your take on it.
Yeah, it's a constant concern of mine that MBSE becomes this ivory tower, this academic pursuit that happens alongside of the development. And lots of times it's actually pitched that way. It's pitched that there's a lot of upfront investment and you got to develop these exquisite models and so on. But I think that can be a mistake if we take that too far. I think really what we need to do, if we want to broaden adoption and make MBSE a sustaining feature of development moving forward, development processes, is to make sure that MBSE finds its place in the development process and does that scope well. So first things first, we need to keep MBSE in its place. There's a tendency to want to continue to grow the boundary of the system model and grow the scope of the model until you're modeling things that are better suited to be contained in other models, whether that's CAD or 1D simulation or so on. So really having the discipline to pick a scope and stick with it and make sure that it's aligned to the development team objectives and it's well scoped. Possibly the second most critical thing to keep in mind when we're developing system models is making sure that they're accessible by other users. That's one of our bigger struggles, actually, and it's the topic of the paper, which we'll discuss further on. But non-systems engineers have a very difficult time making sense of the MBSE outputs, mostly because of the nuances in the outputs. The SysML language is very particular and detailed, and every element in that language means something. So making sure that lay people, for lack of a better term, understand those outputs is critical. And they're able to get to those as well, get to those outputs. And then the last thing I wanted to mention is MBSE needs to be integrated into the development process. It can't be some standalone effort that's occurring outside of the actual development team doing the system design. But Neil, I'm curious what you think on this as well.
Yeah, to build it off exactly what you said, Carl, right? Having the proper scope for MBSE is very important, right? It does become this academic ivory tower, like you said, where people try to cram everything into it. Part of scoping it is knowing the proper tools for the proper job, right? So if you have a requirements tool like Jama, then taking Jama and integrating it with an MBSE tool like Cameo, right? And having information flow between those tools. And then also taking Cameo or any MBSE tool and connecting that to other tools that are the proper tools for the job, right? And having the ability to create that thread across multiple tools and going across multiple different teams and different organizations and having the data flow across is really important, right? And if you're able to do that, it does help the adoption as well. The second part of that is also, like you said, sometimes some teams they have trouble understanding the system out model, right? So things we've done in the past are create plugins that basically take tools that they're used to and create an overlay of a model underneath. So what we do is if it's a safety team that's used to their safety project and their safety tool, we go and create that version of that interface in Cameo. And what they'll do is input in something they're used to, and the models will be created on the back end. Again, helping adoption, helping drive people to achieve that thread. David, back to you.
Yep, and then I'll open this up for either one or both. So what's the biggest organizational or cultural barrier you faced in relation to trying to drive that adoption? And how did you overcome it, or did you overcome it?
Carl, you want to start? Or
Yeah, I can go ahead. I like your last question there. If you overcame your challenge,
yeah.
I would say for myself, my company has been very supportive of MBSE. So in terms of an organizational barrier, there hasn't been a lot. And also the people at my company, they've all been very receptive to MBSE, and they're willing to give it a shot. I've heard a lot about companies or organizations that struggle with adoption because people are resistant to change. And I haven't seen that here. So that really, I can't really speak to that challenge. I think the bigger challenge for me has been following through and capitalizing on that positive first impression, or that fact that people are willing to give it a chance. So like I talked about in my last response about accessibility, I think that really is the biggest challenge for me, is trying to find ways to make the system model outputs useful to other engineers here and other people working within system development. It's the Cameo, like we use Cameo Systems Modeler primarily. It's not an easy tool to learn and understand and use, and it's just not very accessible. So really establishing ways for people to get to those model outputs and navigate through the model has been the biggest challenge for us, and making sure that those outputs are actually relevant to those consumers as well. So I'd say accessibility has been the biggest challenge, and we're working through solutions to that problem. And I think I'll talk more about it, but view and viewpoint modeling is really critical for developing a user-friendly model and developing navigation within the model itself. But also we've also implemented some publishing tools to make the model more accessible to users beyond those with Cameo specific experience.
Oh, that sounds like an excellent way to go about it. Making sure they have the ability to read those models in the way they need. And Neil, do you have any additional comments before we jump to the next topic?
Yeah, so some of the things that I found pretty challenging in terms of adoption are converting people's mindsets. And what I mean by that is people have this traditional document-based way of doing MBSE or doing system engineering. And now there's a new way of doing it that's sort of object oriented, overlaid on top of system engineering, and having people grasp the understand of how you're now creating a database that has single objects that contain the information and that are now going to be referenced throughout your entire system or other models or other programs and so forth. Getting people to understand that concept has been probably the most difficult part, because it's a complete shift and change in a way of thinking, that some people just don't want to learn it, or some people just say, hey, you know what, I'm got 2 years left in my career, I don't care to learn it, keep it going the way I know how to do it, right? So that has been my biggest challenge, I think.
All right. And again, if there's any questions, please put it in the Q&A. Okay, so now that we've talked about, some of the challenges in making sure that you drive adoption and how to get everybody on board, let's talk about some real-world results. Carl, would love to hear more. So if you can tell everyone a little bit about what the REAPr program is it has a really cool name, and why it was a good candidate for model-based systems engineering, and what was the impact?
Yeah, so REAPr is a development effort that's currently ongoing. GS Engineering is contracted to the Marine Corps to develop an autonomous and modular piece of construction equipment. So essentially, it's an autonomous skid steer, but we've developed the system in such a way that that's modular and that the mission function of the vehicle can actually be quickly swapped out based on a modular interface that we've developed. So it's a skid steer, but a little bit more than a skid steer, and it also incorporates autonomous functionality for like mobility operations, whether that's waypoint following or leader follower type operations. And then we're also developing autonomy for the actual mission functions, whether that's train modification or C5ISR or so on. So that's the development effort that I'm talking about when I talk about REAPr and some of our experiences there. So we made a choice when we started the REAPr development effort to integrate MBSE into our development approach. And at the time, MBSE was relatively new to us as a company. So this was really an experiment and something we're willing to give it a shot, but we didn't know for sure quite how to do it and how it would go. But in retrospect, I can say that MBSE has really been a boon for the program, and I'll describe kind of why. And I think it had a lot to do with we picked the right program to do MBSE on. So first, the requirements we received from the Marine Corps were very broad. They were at a mission or operational level, and they were very ambitious. So the requirement set was not well defined, and it needed to be decomposed further, and it also needed to be critiqued somewhat. And using MBSE to decompose those requirements into a system architecture was extremely valuable both to our development team but also for the client, because it offered we took a behavioral approach. So we took the requirements, we built out the use cases and the mission scenarios and built a conOps for the REAPr and used that to decompose our requirements. But really stepping back from a textual shall statement and trying to understand the mission needs helped the Marine Corps reevaluate those requirements that they put down on paper, and actually led to some changes that we addressed before development was too far along. And then kind of last attribute was the REAPr itself is a complex system. It's an autonomous system. It includes hardware and software. It also incorporates modularity, which are all attributes that lend themselves to MBSE and using a system model to visualize a system in a way that with a system this complex, a single engineer is unable to do. It's just not possible for a single person to keep all of the complexity of the REAPr system and the nuances of the REAPr system in their mind at the same time. So MBSE really served us well on this effort, and it's led to some some successes in the development and continuing work on the platform itself. But Neil, I kind of want to hear about your medical device experience.
Sure. So a little different. I think most of the people are usually in the defense space. So medical device is different in the fact that there are no mandates saying that you must do MBSE. There's no deliverables. It has to be purely, there has to be pure ROI, right? Because it's the private sector. If there's no ROI, the company's going to can it. So about 3 years ago, I started working with a medical device company, and me and the lady on the other team started off with just two of us. And then 2 years ago, the team grew to about three on their side. Last year, they were about up to 8, and now I think they're up to about 14 to 20 engineers on this team. And over the years, what we've done is basically started off with small little samples of models to prove the concept of showing modularity, being able to meet FDA standards, not just the US, but also EU standards as well, being able to have traceability of the pieces between different components and so forth. As we began to show the value, more and more people became onboarded. And what we did is we created a onboarding process that says you have 4 phases of levels, right? So the beginner level, you start off at level 1, you are given a sample project, and you have to create a solution in a sandbox. Once you've done that properly, then you can get access to the main model, and then you're given topics and tasks to do in the main model with guidance and overview. And then when you get to level 3, you're basically running your own set of tasks, your own set of things, and you're developing your own portion. And then if you get to level 4, you're managing the meta model on the back end. So how everything's organized, how everything is going to link to itself, profiles, and that kind of stuff. And using these 4-tiered approaches, applying it to the medical device industry, we're able to create a large enough team where now it's successfully producing documents that can go out to different various FDA regulations, EU regulations as well, and also showing ROI to the stakeholders as well.
Yeah, and it's interesting, both of these projects, MBSE had to stand on its own merits. For REAPr, there was no requirement for MBSE in that situation as well, even though it's a defense program. But maybe that's a common thread. Maybe that's where we can see success with MBSE is in the places where we can't relax. We can't do it part way or take the ivory tower approach because it's a contract requirement.
Yep.
MBSE has to stand on its own merits, and that might be a key project attribute as well.
Yep. And you're not just checking a box, right? You're not, oh, you said to do MBSE, so here's the bare minimum, and not actually getting the ROI, right? Just checking that box.
Awesome. Well, thank you both for the overview on actual application and where you've seen success in MBSE drive those results. So looking ahead, it's the thing that everyone can't stop talking about is artificial intelligence and how it's affecting everything. Carl, your experience with GV Set's work explored AI-assisted MBSE. What problems were you solving? Just tell us a little bit more about that.
Yeah, so this goes back to the accessibility problem that I identified pretty early on in building this team and executing MBSE on projects. So we had an opportunity to develop a plugin for Cameo Systems Modeler that increases the accessibility of the model. So our work ultimately resulted in a plugin for Cameo that interacts with a large language model to translate the model that you see on the screen from SysML into plain language. So we did some work on the back end to basically package up a prompt for an LLM and deliver that to the LLM in a format that it could read. And then the LLM was able, with its training data set and its background knowledge of SysML, translate that into essentially a conversational description of either the diagram you see on the screen or the model in its entirety. Really, like I said, this is really focused on model accessibility and allowing people that have low familiarity with SysML or people that get rusty because they don't use this stuff every day. They can really start to interact with the model and understand the various nuances of the various SysML symbols and also the quantity of data that lives in a system model to be able to use it and understand it and deploy it for whatever their needs are. We're also dealing with the need to handle CUI and other types of sensitive data, so that was a consideration as well with the plugin, and choosing an LLM that allows for the handling of that type of data. So ultimately, we developed the plugin, and we're looking at ways to deploy it further and make that a part of our tool set in our development cycle. But it's just one example. It's one small tool that can be used for increasing accessibility of MBSE and really increasing the value add. But it's just an experience we have here at GS Engineering. But I think there's the ways that AI can reshape MBSE is a lot broader than that. But in terms of practical solutions to the problems we see on a daily basis, that was the place for us to start.
Are you allowed to share which LLM it was, or do you have to keep that?
No, so we were using NIPR GPT at the time, so we developed that earlier this year. But we're actually we developed a plugin in a way that allows for swappability of the backend LLM. NIPR GPT has kind of gone out of favor most recently in the government. Most people are using Ask Sage now, and that's a quick update to the API key. So
awesome. Okay.
Yeah.
Thank you. And then Neil, how do you see AI reshaping MBSE and digital engineering workflows?
Yeah, so we took a little bit different approach where we're testing our AI and MBSE integration. We're doing it more on producing new products. So what we did was we took the AI, trained it on a bunch of models, and said, hey, based on these components, these pieces that already exist, I'm going to feed you a new set of requirements. Let's say we have different pieces of a drone. What we say is these are the new requirements I want for a drone. What it would do is go through, look at all the existing components and parts and pieces and try to do a best fit. And after that, it would say, based on your new requirements, based on stuff that exists, here is an 85% solution from all the pieces that you've given me, and highlights the areas of, hey, you have to update these pieces, these voltages, these joints, these whatever the case may be, and go through and say, okay, now based on these requirements, here's an 85% solution. Just take these pieces, update them, and you should have a fairly closely working prototype. So we've been working a lot on that side.
Yeah, that was an interesting. It's the opposite side of the coin here. We were really focused on interpreting data from SysML, but I'm glad to see you guys are working on more of the SysML generation.
On the other side, yep, exactly. Yep, two parts of the same coin.
Yep.
Well, excellent. All right. We have one topic left before we get to the Q&A. I haven't seen any actual questions put in there, but if you're sticking around and you do have any, or just we can even open it to discussion at the end here. So this question I'll just put to both of you. What metrics or signals show MBSE is truly adding value?
Go ahead, Neil.
Sure. Yeah. So one of the key things I've seen is the ability to do requirement impacts and change analysis. And what I mean by that is if you have an existing model and a requirement changes, you can pull up the requirement and say, what are all the pieces connected to this to fulfill that requirement? And if you can then take the pieces, evaluate them, and say, based on the new requirement or the new change, this is the impact that's going to have on my system. From there, you can quantify it and say, in order to really change the requirement, here is the cost to do it for a design that is as is, right? And the other one is gap analysis. So a lot of programs are already existing. You're capturing things and you're looking for gaps in your system. So a lot of times you look back and you say, oh, I actually built a system where I forgot a few requirements, or engineered a bunch of stuff that doesn't map to requirements, and I've over-engineered the systems. Those are a couple ways that we found that help. What about yourself, Carl?
Yeah, that's an interesting perspective. I was taking more of the maybe the project execution perspective or program management perspective, but the way I saw it is if you don't have somebody using your outputs, whether that's the development team or clients or other stakeholders, you fail. the best metric that I've seen in my work is when teams engage with the system model and with the MBSE team to work hand in hand towards advancing some system development or enterprise development. That's the real metric for success. If it's providing value to those viewers or users of the model and they're perceiving the value, then ultimately, there's going to be broad support for MBSE moving forward, and really that increases the value of the work that each of us are doing as systems engineers as well.
Yep, I like that answer better. I'm switching it to that one.
No extra credit here. All right. And then very quickly, and then we'll move it to our Q&A. For a new program starting MBSE, Carl, what do you think the best first step is? And then we'll get Neil's take.
Yeah, Neil kind of covered this a little bit. The best first step that I see is really establishing the parameters for using MBSE on the project. Like I had mentioned earlier, maintaining a scope is very difficult with MBSE or with system modeling, because it just seems like, oh, if we just add this one more piece to the model, or if we just add this one more piece to our system environment, we'll be better off. It makes sense in the moment. But what you end up doing is diluting the value of the system model and spreading yourself too thin across, trying to gather way too much content. So really establishing that scope and those parameters early on is critical. And for that, it includes three things. Or in my mind, it includes three things. One, how does it fit within the development life cycle or development cycle? How is the system model used by the other members of the development team and by users and stakeholders? Second, establishing a style guide is critical, especially when you have more than one person developing model content or multiple people developing model content. Making sure that the elements that you place in the model mean something consistent every time you place them is very critical. And then third, establishing goals and objectives for the model I found to be very useful for maintaining scope and focus on your objectives. So actually defining those in your model and setting those as your starting point, I found is really critical to establishing the parameters as well.
Yeah, I agree with Carl. That top-down approach of defining where your MBSE model is going to live, what the purpose is, what you're going to use it for is so important. Breaking out common pieces and functionality, I think, is another big piece. Defining your libraries, defining your interfaces, defining those things at a higher level so that the working teams all align to it. And that way, when you do integration of models or teams and different things, it all aligns up, right? So if everyone's adhering to the same interfaces, ideally in a perfect world, when you combine the systems together, whether that's subcase of prime contractors or between various teams, everything will align properly and integrate properly. And then having that vision and plan from the top down is very important, right? So if you know exactly where you're going to start, where you're going to end, and then what you're going to use other tools for, right? How you're going to connect them into MBSE, where you're going to run your simulations, where that information is going to come back, what are your testing plans? That full picture is so important, and being able to identify at that level, I think, is very crucial.
Yeah, couldn't agree more.
Well, awesome. Well, that covers all of our key topics that we were hoping to get through today. Now, I'd love to open it up. We do have a question. Rupert had asked, here's some questions to get the ball rolling. You've touched on how MBSE improves cross-disciplinary collaboration. Great work. I'm curious about your take on what are the most frequent barriers to MBSE adoption, and he lists a few: tools, culture, training, or process alignment. Then looking into the future, when we have all of that figured out, what role does MBSE play in enabling digital twins or broader digital engineering initiatives? Curious on your take. So Carl, Neil, either one of you want to step in and give your take on that?
Sure, I can I'll go for it, Carl.
Oh, okay. I think we answered the first one about barriers to adoption. And so really looking forward and enabling digital twins or digital engineering. One of this is something we've started to kind of lean into and experiment with and understand a little bit better. Because our approach generally at GS Engineering has been, let's take the one step that we can at this point. In many cases for us, we're not equipped to develop a full digital engineering environment or full tool stack. Just without a specific project context. So we're really looking at ways that we can start to integrate tools into how can we can start to integrate our system engineering tool into tools downstream and upstream of us within the development process and take those opportunities as they come up. So if we look back at REAPr, one of the things that we really kind of identified early on is the system model really helped us define a visualization or model an engineering environment that allowed the client to see the effects of their decisions very, very quickly. So we operated on roughly 2-week sprints or iterations, and we developed several design artifacts as part of that development effort. One of those was the system model, one of those was the physical realization in the CAD model, and then also we had mission simulation to exercise that system, the physical realization in the mission representative environment. So what we would do is we would get decision making or changes in direction from the client. We would implement those in the system model, and we could visualize the changes to system architecture, and those would also flow into the physical model as well. And we could represent in CAD how the changes to user needs affected the physical solution. And then we're also able to, within that pipeline, exercise the physical model in a mission representative environment for the client, for the end user. So using the system model as a realization of design, we found to be very helpful for moving quickly and moving in more of an agile or iterative fashion with our clients. So, as we move forward, we're looking at ways to integrate the system model downstream with our other design models. But really, even without that integration, without that integrated digital environment, I think there's ways that the system model can practically facilitate more of an agile development approach.
Awesome. Thank you for that. And then I think he was on the first portion of the question, and Neil, I'll put this to you simply because we talked to so many different companies about this. If we had to put more, most frequent barrier to MBSE adoption of these options, what do you feel like comes up the most? Tools, culture, training, or process alignment?
So tools are pretty straightforward. There's a certain set of tools out there that can do a lot of this, right? They have Cameo, which is sort of the forerunner, and then you have other, ANSYS has their tool as well, and there's other tools out there. I don't find that very difficult. Training is pretty straightforward. I know we as Enola offer training, so within a week we can get most people trained up. So that's also not very difficult. Culture and process alignment, however, on the other end are very difficult. Culture is probably the most difficult because if you have someone who sits there and says, I'm not going to learn this, I'm not going to do this because I've been doing document-based system engineering for the last 25 years and I'm not changing my ways, it is extremely difficult to change that person's mind. That ends up being the biggest barrier. Now, ways I've found that help overcome some of these cultural ones is showing the value, right? Taking those document-based models they're used to, whether it's Word, Excel, PowerPoint, whatever they're using, and creating a model that represents the same thing, and then showing how I can simply change a few things in the model and reproduce the Word document, or take them side by side and say, this is where they live in the model, this is where it is in the document, this is where it lives in the model. Watch me make one change, it's across 15 diagrams now, and begin to show the value is how you overcome the culture. Now, the process alignment can become an issue. So ideally, when you're setting up things from scratch or from the ground up, you want to do the process alignment up front, right? Make sure you have that top-down approach where you're taking all the different processes, creating sort of a common process, or at least something that can translate from one to the next, and it's models that will also translate from one team to the next as well. Focusing on the interfaces and where they connect is really important as well. If you do it up front, becomes a barrier that you can get over. If you do it down the line after you've created a bunch of models, it's much more difficult because you're aligning stuff that already exists, right? So hopefully that answers those two parts of the question. And then the second part with the digital thread, where I see MBSE is sort of the portion where a lot of the information is stored post-processing. So initially you have a set of requirements, you create your first set of models, your system models that say, hey, I've conceptually or physically and logically defined my system. Then as you begin testing and doing other simulations and 3D CAD models and so forth down the line, you take the values from those and the results of that and bring it back into Cameo or whatever MBSE tool you have and map it to requirements. And so that plays the sort of a role of like, here's my requirements, here's all my engineering stuff done on the other side, and then Cameo becomes a place where you're just mapping all of it together to show traceability down the line. And then that all leads into digital engineering and twins as well, right? So you have the thread from requirements all the way down to like PLM systems, manufacturing, and so forth. You're now creating a digital thread.
Awesome.
One thing I wanted to add was, Neil, you're talking about, overcoming resistance to adoption. And then I couldn't agree more. Cameo has the capability to build, automate report generation, but you can also build table views that represent or that align to Excel and really establish that linkage between document-based paradigm and the model-based paradigm. And we found that is helpful as well. Neil, to your point, when a user changes a value in the Excel document, we can sync that Excel with the model, and then that model or that element, the changes are kind of distributed throughout the model at that point, and you can really start to kind of get them hooked with the familiar interface, but then also demonstrate the value by the backend syncing and widespread model changes based on this.
Exactly. We've also done where we've created overlays using plugins to create interfaces they're used to. So emulate their software that they're used to using and just auto create the model on the back end. So that really helps with the cultural barriers as well.
Yep.
Well, Rupert, hopefully we answered the great question. Thank you so much for that. Thank you, Carl and Neil. And then Jim Jordan, great, got the thumbs up. Friend of Enola, Jim Jordan, thank you for joining. Had an excellent question and Neil, this might be more for you, Carl, if you feel comfortable talking about V2, absolutely. But since AI works well generating code, what is the difference between SysML 1 or SysML 2? This probably could even be a much longer answer, but Neil, I will let you field that one.
Yeah. So at the base level, SysML1 is built on top of UML as a base language. SysML v2 is completely distinct. It's its own independent language, and it does have the ability to create a flat file. What I mean by that is you not only have a model, there's a parsable or text version that you can create. And what that means is AI is really good at parsing through text. And so V2 is going to be really well built for taking a model, parsing through it, and getting information out a little bit easier. The transition between 1 and 2 is still probably a little ways off. Tools are just now being released with V2 version. There'll be a little refining over the next couple of years, months to years, depending on how long it takes. And then from there, there'll probably be adoption in a year or two is what I'm thinking.
Yeah. I'm really looking forward to a broader adoption of SysML v2. The text representation of the language, I think, is key to facilitating model sharing, making that model more accessible across tools in the systems engineering realm. It's also important for tool integration. I think it'll ease it'll lower the barrier to integrating other tools with the system model, and then also couldn't agree more with the AI insights. That was one of our biggest hangups with our AI interpreter plugin was converting the model into a readable format for AI, which is a text-based format, and having native SysML language in text, I think, is going to open up a lot of opportunities with AI integration and really make AI kind of the sidekick for any systems engineer moving forward.
Awesome. All right. Well, I don't see any more questions. If anybody has any, feel free to put them in the chat or the Q&A. We're happy to stick around. I know we're a few minutes over. Otherwise, if you're interested in talking with the folks at Enola, myself or Neil even more, here's our contact information. And also GS Engineering, Carl Jolma, you can find him on LinkedIn or their website, gsengineering.com. If you are interested in looking into their menu of services in really across industries for engineering and specialty offerings. So again, thank you, everybody. I'm not seeing any more chats or anyone else with any more questions. Jim and Rupert, thank you for those. And again, thank you all for your time. Neil, Carl, thank you so much for this awesome discussion, and hope you have a great day. Thanks, James. Take care, everybody. We'll send out a copy later if anyone wants to recap it.
Yeah. Thanks for attending. Thank you, David.
Bye, guys.
Yeah. Thanks, everyone.